Hello, Advanced Algebra 2. Welcome to the Concept 26 notes. We're going to look further at logarithms and their graphs. We're also going to circle back to exponentials and their graphs, especially when we have some transformations involved. So let's get moving. Graphing log functions. Here's the important stuff. So to graph a log function, you're going to start with the y values, because we're going to think of it in exponential form, and your y value will be your exponent. We'll let y equal -2 to +2, and then solve for x. If we get into log function translations, we'll look at what the h and k values are. Then we will graph the function without, and when I say graph, I mean find values in the table without h and k. Then we'll translate the graph h units and vertically k units through our table. In a log function, the range then has a domain of all real numbers. And then our domain is what's limited. And that'll become more clear as we graph some of these. Also, with a log, we will have a vertical asymptote rather than a horizontal asymptote like we had for exponentials. So let's start with this function, y equals log base 3 of x. Let's just switch sides here. Log base 3 of x equals y, so then we can write it in exponential form easily. So that is 3 to the y equals x. It's most easy to think of a log equation in exponential forms to get values and points. If we leave it in log form, then we have some limitations that we come across. So now we'll let our y values be -2 to +2. It's normally not what we do. We usually put in x values and get out our y values, but we can work the other way if needed. So now let's see what our x values equal. So 3 to the -2 rounded is 0.1, a tenth. To the -1 is 0.3. To the 0 is 1. To the first power is 3, and to the second power is 9. Draw your xy axis, label it, and label a scale. And now carefully plot these points. It's going to feel a little backwards. So we'll go over 0.1 down -2, over 0.3 down -1, etc. And then you'll see a log curve emerge. It looks like an exponential curve on its side, and it has a vertical asymptote. This curve is going up against the y-axis. So no matter what power we raise y to, x will not be 0, so it won't put us right on that y-axis. Our domain is limited. We can only plug in values, and our asymptote is the y-axis, and that's the equation x equals 0. Our domain are all of the x values that are greater than 0, and our range is all real numbers because all those y values will be used. So in a lot of ways, it's opposite of an exponential curve. Now let's look at y equals log 1/2 of x. So we'll rewrite it with our log expression on the left side of the equal sign and then change it to exponential form. So 1/2 to the y power equals x. Then we'll let our y values equal -2 to +2. Plugging those in, we'll get 4, 2, 1, a half, and a fourth. So draw your xy axis, label it, and label a scale, and then carefully plot these points, because again, it feels a little backwards. Now you can see that this log function, rather than rising as you look at it left to right, it drops. And if you look at the equation, it makes sense because the base is 1/2. It does have a vertical asymptote right at the y-axis, or where x equals 0. Our domain are the x's that are greater than 0. Those are being used for the curve, and our range is all real numbers. Now we have some transformations happening, so we're going to pick out our h and our k values. Our h value is -3. Remember, it's opposite sign. We'll come back and talk about the shift. Now we'll do the shift in the table, so we're shifting 3 to the left. So we're going to subtract 3 from the x values, and then the k value is positive 1. So that's a shift up, and we're going to add that to the y value. So h gets added or subtracted to x, k gets added or subtracted to y. And then writing that equation in exponential form, it's 2 to the y equals x. All right, now let's plug in values, -2 to +2 for y, and put it in the equation. 2 to the y equals x, so we'll get 1/4, 1/2, 1, 2, and 4. And now let's do the shifts in our table. So we're going to subtract 3 from each of our x values. That will shift the graph 3 to the left, and then add 1 to all of our y values. So we've done the shift in the table of values. Now let's plot the points. So draw your xy axis, label a scale. I noted that we're shifting 3 to the left and 1 up. And then I'm just looking at the numbers in red for my points. I can see that I have a log curve, and it's shifting 3 to the left. It's going right up against the line x equals -3. That's what we call our vertical asymptote. An asymptote is a limit in the graph of some functions. Now we have y equals log, that's a base, 1/3. I didn't get that subscripted, x minus 3. So we do have a shift 3 to the right. Our h value is +3. So we'll do that shift in the table. Our equation without that h value is y equals log base 1/3 of x. And in exponential form, that's 1/3 raised to the y equals x. And then go ahead and put the +3 in your table by the x values. So, since our y is our exponent, we're going to plug in values -2 to +2 for y. We will get 9, 3, 1, 1/3, and 1/9 for our x values, and then add 3 to all of those for our shift. So 12, 6, 4, 3.3, and 3.1. Draw your y axis and label a scale, and then plot those points with our shifted x value and our y value. So now you can see that log curve. It drops as we look at it left to right because our base was 1/3, and it goes right up against that vertical asymptote of x equals +3. Our domain are all the x values that are greater than 3. Our range is all real numbers. All right, now let's shift to some exponential graphs. So I have given you the exponential equation now with our a, h, and k value in it. Also, there's the log with a, h, and k. Let's hold on a moment. So we're going to graph y equals 3 to the x minus 1 power. So we have an h value. It's up by the x. It's +1, so we're shifting 1 to the right. So that means in our table, we will add 1 to the x values. And then into our equation, we're going to ignore it. Y equals 3 to the x. Since x is our exponent, we'll plug in values -2 to +2 for x. See what we get for y, which is 1/9, 1/3, 1, 3, and 9. And now we'll do that shift for our x value, 1 to the right, by adding 1 to all those values. All right, and it looks like I am going to back up here because it looks like I forgot to do that. So we'll have -1, 0, 1, 2, and 3. Now we've got our shift to the right. There, you can see it with our original graph. Our domain is all real numbers because we're back to exponential, and our y's are all the values that are greater than 0. Now we have another exponential to graph. So y equals 2/3 raised to the x plus 1. We've got a k value, and that means our graph is going to shift 1 up. So we're going to add 1 in our table to the y values. And then to get our initial xy numbers, we will just have y equals 2/3 to the x. Since x is our exponent, now we'll plug in values from -2 to +2, get our y values, and then hopefully I will not forget to add 1. Oh good, I don't. So 3 1/4, 2 1/2, 2, 1.7, and 1.4. Draw your xy axis and label a scale, and then carefully plot those points. So we should see a shift of exponential decay, which is up 1, and we do. I dashed in, we have a new horizontal asymptote. It's moved up 1 from our x-axis. Our domain are all real numbers, and our range are all the y values that are greater than 1. It will never touch that line where y equals 1. All right, our next equation is y equals -2 raised to the x plus 2 minus 2. So I have both an h and a k value. So my h value is -2. I'm shifting 2 to the left. And then my k value is also -2. So I'm shifting 2 down. So hopefully, I also have an a value of -1. And that's a reflection over the x-axis. So hopefully you're used to the process now. We're going to, with our h value, subtract that from x, and our k value, subtract that from y. And then for our numbers in the table, we will just look at y equals -2 to the x. We will ignore our h and k. We'll plug in -2 to +2 for x, and we'll get -1/4, -1/2, -1, -2, and -4. And then we'll subtract 2 from our x values and subtract 2 from our y values. Draw your xy axis and label a scale, and then carefully plot those shifted values. So you should see exponential growth that has been a reflection of exponential growth that's been shifted 2 to the left and 2 down. All right, and one more exponential to graph. Y equals -3 times 3/8 raised to the x. So no h and k values, but we do have an a value. Now I say it's -1, but it's actually -3, and I'll go back and fix that. So we have an x-axis reflection, and we have a vertical stretch by 3. So plugging values in for x, and then we put it into the equation as we see it. All right, and there I note that we have a stretch by 3. So drawing your xy axis, and notice I switch my xy axis around based on my values. So I have lots of negative here in my y values. And then I plot them. My first point is going to need to go off graph because I'm -21.3, just a little bit though. Now -1.8, 0, -3, 1, 1, 1, sorry, 1, -1.1, and 2, -0.4. So now as you see, we've got a reflection of exponential decay that has been stretched. It goes right up against our horizontal asymptote of the x-axis. It has a domain of all real numbers and a range of the values, the y values that are less than 0. All right, that concludes part 1 of our concept 26 notes. So part 2, we're going to look more at some logarithm graphs and equations.